Okay, so we just learned about exponential functions, and a good thing to do when you learn something new is to compare and contrast it to something you already know. So you guys already know lines, and we can see that the x is right here in our equation of a line. It's not in the exponent, but in the exponential function, we see x is in the exponent. So there's our compare and contrast of equations. The other thing is the exponential function comes from repeated multiplication. Right? I multiply by b over and over and over. That's how I get an exponent. Where the linear function right here, the m times x, that's repeated addition. Right? It's x times x times x, or I should say, sorry, m plus, it's addition, m plus m plus m plus m, x times. Let me show you how this works. So for a linear function, if I were to write that out differently, I would say f of x equals b, my starting amount. I start with b, and I'm going to add m and add m and add m, and I'm going to add m over and over, and I'm not going to specify how many times. I'm just going to say that I'm going to do it x times, and the shortcut way to write that would be b plus m times x, because multiplication is a shortcut. So it could be b plus mx or mx plus b. You could switch it around. That's okay. So that's repeated addition. That means you're going to always just be adding the same amount. Adding as x increases, you keep adding the same amount. Here, for exponential functions, to compare and contrast, we have our starting value a, and then we multiply b times b times b times b, and we're not going to specify how many times. We're just going to say x times. So here we might start with an amount of 4, and then we're just going to multiply by 3 and multiply by 3 and multiply by 3 over and over and over, and that makes an exponential. When you do that, when you do repeated addition, if you just always like add 5, add 5, and then go over again and add 5, and go over the same amount and add 5, you're going to get these points that line up perfectly in a line. Okay? So linear growth happens at a constant rate because you're always just adding 5. The rate doesn't change. Okay? It's occurring at a steady rate. When you do exponential, if you multiply, when I go over a little bit, I multiply by 2, and now I have a bigger number. And when I multiply a bigger number than before by 2, it gets even bigger. I have a bigger y value. And then when I multiply by 2, it's going to grow even more. See those up lines here, the lines that go vertical, the growth? They get longer and longer and longer, where these stayed the same. So that's what's going to happen with the multiplication. In exponential growth, the rate of growth is changing. Okay? It's actually increasing along with the growth itself. Now, keep in mind, we could also have exponential decay. It doesn't always have to grow, right? Something can decay and get smaller and smaller and smaller. And the same rule applies in reverse, meaning the amount that I go down. So if I move over and I go down a certain amount, let's say I'm dividing by 2, or actually I want to say multiply by 1/2. Then when I go over the same amount, now I multiply by 1/2. And then I go over the same amount and I multiply by 1/2. You can see the amount that it drops each time gets less and less and less. So if it's decaying, the change will get smaller and smaller and smaller. If it's exponential growth, the change will get larger and larger and larger. Okay? So that's the difference between the two. It's good to compare and contrast to something you already know. So here's some tables. Determine if the table represents a line or an exponential, a linear or an exponential. So what I'm going to do is I'm just going to analyze how much the y changes by. So right here, to go from this y to this y, it looks like I added 5. So then I just want to see if it's the same thing over and over. That would be linear. Yeah, I added 5. I added 5. So since it's repeated addition, that's linear. All right, that table's linear. Let's look at this table. To go from 50 to 20, it looks like I subtract 30. That's the same thing as addition, right? But then I don't subtract 30 again, so it's not repeated addition or repeated subtraction. So it's not linear. That means it must be exponential. So maybe I multiply by a number to get from here to here. Now, the thing is, if it's getting smaller, you're actually multiplying by a fraction. So how would we figure out what number we're multiplying by? Well, I could take the 20 and divide by the number before it, 50, and I get 0.4. So I can change that to a fraction. It would be 2/5, or I can look at it as 0.4. All right, so let's use 0.4. I'm multiplying by 0.4. Now, to go from 20 to 8, I guess I would multiply by 0.4. Let's see if that's right. 20 times 0.4, I get 8. So that means I must multiply by 0.4 again. 8 times 0.4 will be 3.2. So this one is repeated multiplication, and the shortcut for repeated multiplication would be to use an exponent. So this one is exponential. If I were to write an equation for this one, I really like to do this here. The starting amount is 50, and then I multiply it by 0.4, and I multiply it by 0.4 over and over and over. So if I were to write that in a shortcut, it would be y equals 50 times 0.4 x times. And that's how you write an equation from a table for exponential. It's not that bad. You write the initial amount 50, and then the 0.4, that's the thing that you multiply by over and over again. I actually want to look at something here. Did we, when we did these notes up here, did we define it yet? No. Okay. So that's how we write that equation. State whether the graphs are linear or exponential. The exponential ones are going to have that nice smooth curve that all of a sudden explodes up and the growth really grows quickly. Or they could be going down quickly as well. And then this one's linear. So it looks like exponential and exponential. And the ones that are straight lines are linear. All right, so now determine if the table represents linear or exponential, and write the linear or exponential equations and contrast them. All right, so again, we're going to analyze what's happening here from each y value to the next. Looks like we add 2, we add 2, we add 2. So this one's going to be linear because it's repeated addition. And if I'm making an equation, I'll say f of x equals the first value 0 plus 2 plus 2 plus 2 plus, I'm going to do that x times. So what I write is 0 plus, if I have repeated addition of 2, multiplication is the shortcut. So I'm going to do 2 times x. And then because it starts at 0, I can just drop the 0 because plus 0 doesn't do anything. So this one would just be f of x equals 2x. For this table, it looks like I add 1, but then here I add 2. Then I would add 4. Okay, it's not a line. So maybe I multiply by something. It looks like I multiply by 2, and then I multiply by 2, and then I multiply by 2, and then I multiply by 2. So this one is exponential. So when I write the equation, it's going to be g of x equals the initial value 1, and then times 2 times 2 times 2 over and over. I'm going to do that, say x times. I'm not going to specify how many times. So then I could write it as g of x equals 1 times 2 to the power of x. Because I have repeated multiplication, x times, that means that becomes an exponent. So times 1 doesn't really do anything, so I can drop the times 1 and just call it 2 to the x. Okay, so you can contrast, and I think we've already done that enough. But in the linear table, we have repeated addition. And in the exponential table, we have repeated multiplication. Okay, so now they want us to write the exponential equation for the given tables. So I've been, these are all exponential, right? So I've been shortcutting or not explaining fully how you identify the initial starting value. And the general form, by the way, that we're going to use is y equals a times b to the x, where a is the initial amount and b is the factor. Factor is the thing you multiply by over and over and over. How do you identify the initial amount? You're looking for when x is 0. Once you know x is 0, the starting amount or initial amount is that y value. So 3 is my starting amount or initial amount. So my a is 3. My b is my factor. And factor is what you multiply by each time. So again, it looks like it's times 2, times 2, times 2. So I have a factor of 2. Then they want us to write the equation. Well, I like to write it out this long way first. Y equals, I start with 3, my a value, and then it would be times 2, times 2, times 2 over and over and over again. So it's going to be y equals, 3 times 2. How many times are we going to multiply 2 together? That was what the exponent would be. We're not specifying because sometimes we want to do it just twice, or if we want to check the 10th number on the table, we got to plug in a 10. Or if we want to check the millionth number on the table, we got to plug in a million. So we're not going to specify how many times we're going to multiply by 2 over and over. We're just going to put in x, and that's the equation. All right, let's look at this one. My x is 0, so that means that's my initial value. That's my starting amount. Then I have to see what I'm multiplying by. Oh, the numbers are getting smaller. So it looks like I'm dividing by 10. Here's the thing. For exponential equations, you always have to do multiplication. So dividing by 10 is the same thing as multiplying by the fraction 1 over 10. And then I multiply by 1 over 10. And I multiply by 1 over 10. So it looks like my b is 1/10. So then it wants my equation. Well, I like to do the long one. So g of x is my starting amount times 1/10 times 1/10 times 1/10 over and over and over. So my equation will be 100 times 1/10 to the power of x. All right. Write the equations that model the exponential functions in the graph below. If you have a graph, just identify the numbers and it'll be just like the table. When the x value is 0, that y value is the starting amount. So that's our a. And then what would I multiply 8 by to get 4? I would do 8 times 1/2 would give me 4. So that's my b value. Then if I multiply 4 times 1/2, I would get 2, right? And so that's why this point would be right here. This would be 2, 2. Because my 8 would get cut in half to 4. Then I would multiply by 1/2 again to get 2. Then I would multiply by 1/2 again right here to get 1. That would be 3, 1 would be that point, right? Multiply by 1/2 again, and I get 1. So it looks like I'm multiplying by 1/2 over and over and over. So they want the equation. So my starting amount here, I'm going to say y equals, my starting amount is 8, and then I multiply by 1/2 over and over. So it's 1/2 to the x times. All right, and then this practice we'll do in class. This is the practice for you.